Today's video will be on gradient. Okay, so our learning goals for today. By the end of this lesson, you'll be able to use the gradient formula to calculate the gradient of a line, and you'll also be able to use the gradient formula to calculate the gradient between two given points. Okay, so some key ideas about gradient. The way we calculate gradient is we use this formula here. So we've got gradient, which write as m, is rise over run. So the rise can be positive or negative, and rise is just the change in our y value. So it's this kind of change. When we work left to right, has that y value on that vertical axis has that increased. And the run is across our x-axis, and because we're working left to right, it's always going to be positive. Because you think of our axes, as we move across our axes, we're going left to right, so we're moving this way across our axis. It's going to get bigger. Our numbers are going to get bigger. So a gradient can be positive, negative, zero, or undefined. So if you look at this picture here, we've got a positive gradient. The run is always going to be positive because we're going from left to right, so the x value is always going to increase. And the y value may also increase. So if you've got a line that looks like this, the y value is increasing as you move left to right, and this will be the rise here. The opposite is for negative gradients. So the run, moving left to right, again, is still going to be positive, but the rise is going to be negative because if your graph goes like this, if we're working left to right, the height will start here and go down, so it's decreasing. So you can see in our picture down the bottom, we've got a few more examples of different gradients. So in the red there, they've got a positive gradient. You can see as you move left to right across the screen, the y value would increase. Because it's starting down here, this might be what, -1, 2, maybe -3 down here, and it's going up to, this point here perhaps, where you're looking at more of a positive number, so it's increasing. The negative gradient is in blue. As you move left to right, that y value gets smaller. We're starting here, which would be a positive y value, and as we move along our graph, we finish way down here, and that would definitely be a negative y value. We've also got undefined gradient in purple, so any vertical line will have an undefined gradient, and in green it's a zero gradient. So any horizontal line will have a zero gradient because as you move left to right, it's not changing at all, so it's called a zero gradient. So to calculate the gradient, as I said, we use the formula gradient, which is represented by lowercase m, equals rise over run. So to calculate the rise, we do y2 take y1 divided by x2 takes x1. So if you were to have a Cartesian plane just like this, so this would be a Cartesian plane, you've got your x-axis here and your y-axis here, and you might have a line that's going through your Cartesian plane. So if you can get the coordinates from this point and this point here on your left, that would be x1, y1, and the point up here would be x2, y2, and we know that because we always work left to right, so whatever point is on the left will be the first one, and the point that's on the right will be the second one. Then we can just use those coordinates, plug it into our formula, and calculate the gradient of that line. Okay, so now I've got some worked examples here, finding the gradient of a line. So for each of the following, state whether the gradient is positive, negative, zero, or undefined, and then calculate the gradient where positive. So the first thing I'm going to do is decide whether we've got a positive, negative, zero, or undefined gradient. So the line isn't horizontal, so we know it's not a zero gradient. It's not vertical, so we know it's not an undefined gradient. We just have to decide whether it's positive or negative. So once you've done a few of these, just by looking at which way the line is facing, you'll be able to work it out. But for the sake of this video, we'll step it out right from the basics. So if we drew a dot, on the left here, let's go with this point here, and then somewhere on the right, because remember our gradient works left to right, we can work out whether it's a positive, negative gradient. So our y value started off at -2, and then up here it's sitting at about 3. So from -2 to 3, that's obviously an increase. So it's increasing, which means it's a positive gradient. So this one has a positive gradient. So the next thing we have to do is calculate gradient. So our formula for gradient is our rise over our run. Rise divided by run. So to do that, we're also going to do y2 take y1 over x2 take x1. So with your line, you can pick any point you want. Obviously, if it's sitting directly on a point, it's going to be easier because you're not dealing with decimals or anything like that. So I think this one right here is on the line. So I'm going to use this point here. The coordinates of that are 0, 2, and this point that we drew originally, the coordinates are -3, -2. So then I'm just going to plug those in. So remember the one on the left is going to be the the y1, and x1, x2. Start again. This point here will be x1, y1, and this point here will be x2, y2. So we're just going to plug those numbers into our formula. So y2 is 2, take y1, which was -2, divided by x2, which was 0, take x1, which was -3. Now obviously in your books you would set that out a lot more neatly than I am. You're not going to go on an angle, you're going to go down the page. I've run out of space, but in your own books you would continue working down the page. So 2 take -2 is the same as doing 2 plus 2, and 0 take -3 is the same as doing 0 plus 3. So it leaves us with 2 divided by 3. So that would be our gradient there. So what you could do is you can leave it as a fraction, but obviously you're allowed to use your calculators. So if you need to, you can type that into your calculators there. So 2 divided by 3 would leave me with a decimal, 2/3, so 0.6 reoccurring. So we'll just do 0.6 reoccurring. Or you could round to 0.67, but you can see there it's a positive gradient. Okay, for our next one, we've been given 2 points on that graph already. I'm not sure if you can actually read what these say, but so I'll write them a bit bigger here. It's -2, 3 are those coordinates, and this one here is 2, -1. Okay, so the gradient, we're looking at that. It's not undefined, it's not 0. Our y value, how is our y value changing? Well, it starts as 3 and then it ends as -1, so obviously it's decreasing. So you'd say we have a negative gradient on this graph here, negative gradient. Okay, so now we have to calculate the gradient. So gradient equals our rise divided by our run, which is y2 take y1 divided by x2 take x1. So remember working left to right, so this would be x1 and this would be y1 and this is x2 and this is y2. So y2 is -1, take y1, which is 3, divided by x2, which is 2, take x1, which is -2. Okay, so -1 take 3 will leave us with -4, divided by 2, take -2 is the same as adding, divided by 4, so -4 divided by 4 will leave us with -1. So our gradient on this graph here is -1. Okay, our next gradient here, you can see we've got a vertical line. So a vertical line will have an undefined gradient. So we'll just write undefined, if I could spell, undefined gradient, and because it's undefined gradient, we can't actually calculate it, so we just have to leave our answer like that. Last one here, we've got a horizontal line, so we have a 0 gradient on our horizontal line because you can see our gradient actually doesn't change at all, and again, we don't really calculate that, we just leave it as a 0 gradient. Okay, so worked example, finding the gradient between 2 points, find the gradient of the line joining these given points. So A, we've got the coordinates of A, and B, we've got the coordinates there. So for A, we're going to use our formula, gradient equals rise over run. So we've got y2 take y1 over x2 take x1. So y2 in our first example is 6, y1 is 4, x2 is 5, x1 is 3. Again, you're going to work down the page. I've just run out of space, so I'm going to do it beside it. So 6 take 4 is 2, 5 take 3 is 2. So 2 divided by 2 is 1. So we've got a positive gradient there of 1. Ooh, that was not a very straight line. Ugh, it's getting worse. Okay, so I'm just going to rule my page in half. Remember, please make your books a lot more neat than what my writing is. You should be doing the equal signs as I am, but just work all the way down the page. So for our second one, we're going to calculate the gradient again. So we've got y2 take y1 over x2 take x1. So y2 in this case is -3 and y1 is 6. X2 is 1 and and x1 is -3. So Negative 3 take 6 is negative 9. 1 take negative 3 is the same as adding, so it's the same as doing 1 plus 3, which is 4. So you've got negative 9 divided by 4. So a negative divided by a positive, we're going to have a negative answer there. I can't do that in my head, so I'm going to grab my calculator and type in negative 9 divided by 4 is 2 point something. There we go, 2.25. So negative 2.25. So you've got a negative gradient there, so obviously the line's going to be going, this way, that way, this way, which way is right in the camera. It's going to be going negative anyway. So it's a negative gradient of negative 2.25. So that's all we have for our video on gradient today. If you have any questions, please come and see me in class.